Okay, good morning. Let us continue our lesson with the quadratic functions again. So we learned that a function of this form is called a quadratic function. F of x equals to ax squared plus b of x plus c, where a is a non-zero real number, yes? And we also explored some properties of the graphs of these functions. There are one more feature of the graph of this function that we want to explore today, and that is the idea of symmetry of the graph. So it is symmetric. So if you have drawn the graphs using, for example, GeoGebra, you see always that you can split the graph into two more or less two identical parts, yes, by drawing a very nice line. For example, the most famous quadratic function is y equals to x squared. So if you draw it perfectly fine, then you will see that this part is the mirror image of this part regarding with respect to the y-axis, yes? But this is the general feature, not only for this simple one. For this simple one, it is understandable, yes? Why it is understandable? Because, of course, if I put 0, I get 0. If I have a table x and y, if I put 1, I get 1. But if I also put minus 1, I will get the same 1. So it means that if I am on the left-hand side, x is 1. If I am on the right-hand side, x is 1. On the left-hand side, x is 1, minus 1. Both of them will give you the same height. Yes? So this means that these two are mirror images of the other. But what happens about this? Do you think that this also have, in general, do you think this also has a symmetry, a line of symmetry or not? So here, the y-axis is the line of symmetry of this parabola. Yes, you want to explore that one. But before doing that, let me ask you some questions to see how you can answer this question. Yes. So if I give you a point here, say for example, its x coordinate is a, and its so here its y coordinate is b. If I reflect it about the y-axis, what do you get? You get another point. So let me call this point A. Let me call this point B. So can you read the coordinates of point B now? If I give you A, if I give you B, and then you reflect this point about the y-axis, and you get another point. So B is the mirror image of A regarding this. I'm asking you, can you tell me the coordinates of B now? Yes?
Minus AB.
Minus AB, so it's minus AB. Now let us explore this question not just for y-axis, for any vertical axis. So for example, let me just start with a number first. For example, I draw this. Let us consider that this is x equals to 2. Yes? And what do I do? For example, let me choose this point minus 1 and this point 2. And let me call this point A. The coordinates of point A are minus 1 and 2. Yes? And now what I want to do, I want to consider this as your mirror and find the mirror image of A with respect to this mirror. Okay, so what should I do? I need to take this point and drop a perpendicular line to this mirror. And whatever this distance is, I have to continue from the other side. Yes? And then I reach to a point, let me call it B, and then I want you to answer these two question marks. One of the question marks actually doesn't need any calculations at all. Which one? The y. So because you are not changing the height by doing this, so if that coordinate was 2, this coordinate is still 2. So no worries about that. So nothing will change in this. But what happens for the other question mark? Can you answer that? So I told you this number is 2 here. Yes? 5. It is 5. Why? Because you are telling that the distance from -1 to 2 is 3 units, and I am going 3 units to the right. It is 2. I go 3 units to the right, so this question mark becomes 5. Yes? Is that understandable? Okay. But another way to see this, can you tell me what is the coordinate of this point? What are the coordinates of this point? X is what? 2, and y is also 2. Now, if I ask you what are the coordinates of A, you would say -1 and 2. And then do you agree that this point, let me call it M, is exactly the midpoint of A and B? So, you can answer this question in a little bit different way. Okay, so you would say that let me call this one X of B, and let me call this one Y of B. We already know the coordinates of the middle point, and we know that based on what we have learned before, the coordinate of the middle point, xm, is xa plus xb divided by 2, and ym is equal to ya plus yb divided by 2. In this one, do I know x of m? Yes, x of m is this point, so I know it. Do I know x of a? Yes, I know it, so the only question mark left for me is this one. So I can solve this equation and find x of b by making x of b alone. Yes? This is probably a little bit better way to do it. So let us just try to understand it in this form. I draw another system for you here. I just choose randomly a number here, positive, 0, or negative, it doesn't matter here. So let me call it alpha. Yes? And then I draw a vertical line. And then I choose any point that you like on the plane. For example, let me choose a point here, for example, A, and then let me call it A and B. So if you don't mind, let me change the notation to x of A and y of A. Okay? And then I want you to find a formula for its mirror image. So this is point B. I want you to tell me, if I give you alpha, if I give you A and x of A and y of A, how can I find x of B and y of B? Yes? Y of B is exactly equal to y of A. Yes, that's clear. So you don't need to do anything. So y of B is equal to y of A. So this question mark is answered because I'm not changing the height by dropping perpendicular lines. But can you tell me what are the coordinates of this point now? If I call it M, what are the coordinates of that point? What is the x coordinate of that point? Yeah? What?
Never mind, alpha.
Alpha. It's alpha because that is the line x equals to alpha. And then the other one. What is the y coordinate? Ya. Yes? And I know that M is the middle point between A and B. So x of M is equal to x of A plus x of B divided by 2. Instead of x of M, I put alpha. Instead of x of A, I don't know it. So I know it, I just put x of A. X of B is my target. I need to find this one. I multiply by 2, so it becomes 2 alpha is equal to x of A plus x of B, but I am looking for x of B. So x of B becomes 2 alpha minus x of A. Yes, so that is a very nice formula. So if I have this point A with coordinates xa and ya, if I do this mirror image, this point will go to the point B with coordinates 2 alpha minus x of A and y of A. Yes, in this kind of transformation, any point with coordinates x of A and y of A goes to this point with coordinates 2 alpha minus x of A and y of A. Is that understandable? Okay. Now, let us go back to the case of this parabola. So I want you to use this. My claim is this. So this is my claim. Let me write the claim here. And then we want to see why this claim is indeed true. The vertical line x equals to minus b over 2a is the symmetry line of the parabola y equals to ax squared plus b and bx plus c. Okay, how can I prove this claim? And then I want you to memorize that. This is given, of course, I think, in the formula sheet. But that is, do you remember, that is the famous number we had it before for the turning point, yes? So for the x-coordinate of the point, turning point. So what I'm claiming is that, do you remember we discovered that before? For example, if I have a parabola, in this case a is positive or negative for this picture? It's positive. Do you remember? I told you that if a is positive, the parabola opens up. If a is negative, the parabola opens down. So in this picture, a should be positive. And then, do you remember, we got a formula for the turning point, the coordinates of the turning point. If you refer to the notes, you will see that this was what? Minus b over 2a, and then 4ac minus b squared over 4a. That was the formula that we found for the coordinates of the turning point in general. Yes? And now I am claiming the vertical line x equals to minus b over 2a is the symmetry line. So what does it mean? It means that if you draw the vertical line x equals to minus b over 2a, which is exactly this number, so that will be that would be this line. This line is the line of symmetry of this parabola. So then this means that this part of the parabola will be the mirror image of the other parabola. So you need to understand, when I say x equals to minus b over 2a, it definitely passes through the turning point of the parabola. And it is vertical. But I haven't shown this, why this is true. Okay, can you guide me how to prove this? We want to show that this is really true, that if I draw this vertical line, it will be the symmetry line of this parabola. According to what I try to tell you there. Just tell me your strategy, the details, the algebra, I can do it for you. But how do you think about the problem? Guide me step by step. I will do the algebra. You will tell me how to do it, yes? No, you will tell me what to do, I will do it for you. So what is the meaning of this line to be a symmetry line? It means what? It means that if I choose any point on the parabola and I find the mirror image of that point with respect to this line, it will end up somewhere on the parabola. Yes? That is the meaning of being symmetry line. Is that understandable for everyone? So when I say that, I am claiming that this line is the line of symmetry. What does it mean? It means that if I choose any point that I like on this parabola and find the mirror image of that point with respect to this vertical line, it of course becomes a point, but I want to claim that, I'm claiming that that point definitely lies on the parabola again. If the line is not, if for example, if this line is not the line of symmetry, for example like this, yes, this is not the line of symmetry. And what happens if I take this point find its mirror image, it becomes here. And this is no longer on the parabola. And this is clear, this is not symmetric with respect to this line. So if I want to prove that this line is the line of symmetry, it means that any point that you choose on the parabola and find its mirror image with respect to this line, it will end up on the parabola again. So that is the strategy. Yes? Now that you have this strategy, the details is just algebra. So, but you can help me to do the algebra now at least, yes? So what do you think? I choose a point here, any point, so let me call the coordinates here to be, I don't know, let us be careful about, so let me call it alpha and beta. Or it might be alpha and beta are not good choices here. So let me call them u and v, yes? I choose a point on the parabola. I don't know the coordinates because this point can be anywhere on the parabola. So let me call its x coordinate to be u and its y coordinate to be v. Okay? And now I am asking you, can you tell me the coordinates of this point? So let me call this point point A. I want you to tell me what are these question marks using what we had before. The second question mark you can answer first. So what is the second question mark? What is the second question mark? Yes?
It's V.
It's V, yes? Because no height is changing. But can you tell me what is the first one? Look what I told you there. So you see, we had the formula here. X of B is 2 times alpha minus x of A. But what is playing the role of alpha in this setup? Yes?
The midpoint.
No?
The symmetry line.
Okay, so what is that? Just give me something concrete. What is alpha? Alpha is this number. So what is alpha in this setup? Yes, Ali?
Minus b over 2.
Minus b over 2a, yes? So, and then what I have to do, I have to multiply alpha by 2. So what I have to do, I have to multiply alpha by 2, and then minus, can you tell me what? Minus x of a, x of the starting point. What is the x of the starting point? Is u. Yes? So I have to write u. I want to wait for you to digest what I have written here. So you see, I took a random point on my parabola. So I called the coordinates u and v. And then I found the mirror image of A with respect to this dotted line, which passes through this point, and I am claiming it here. And then I called it point B. Definitely the second question mark is the y coordinate of A because they are on the same height. So if this is V, the y coordinate of B is also V. But what is the x coordinate of B? The x coordinate of B is done here. It is 2 times alpha minus x coordinate of your starting point. Alpha is this number here, yes? So it is 2 times alpha minus the x coordinate of your starting point, which is u. Yes? Yes or no? Understandable? Okay, but let me simplify that. These 2 and that 2 are gone now. So this becomes minus b over a minus u and v. Yes? Okay. First of all, tell me, are these things that I mentioned understandable? Yes? Okay, now tell me, how can I prove that? I chose point A on the parabola. I am claiming that the resulting point is still on the parabola. I want you to translate this into mathematical language. So A, U, and V lies on the parabola. From this sentence, Okay, you can tell me, I can conclude what mathematically? What can I conclude? Today, are you sleepy? Yes. So what is this one? I don't know. This should be a matter of milliseconds to tell me what to write. These are there are some anchors in mathematics. You need to learn them very good. It should be very automatic in your brain. If a point is on a graph, what is the consequence of that? Just learn it once for all, for God's sake, okay? So what is the consequence of a point being on the graph? Yes?
If we put
Yes, thank you. Yes, because this means the coordinates satisfy that damn equation, yes? As simple as that. Is that understandable or not? Just learn it, yes? Just concentrate, promise yourself that you learn that and you will never forget until you die. Yes? Did you promise yourself that? As simple as that, yes? Okay, so now what happens? So just tell me, it means that because this point lies on the parabola, y, I myself chose it there. So it means that if I replace y with the y coordinate and replace x with the x coordinate, then what will happen? This becomes a true equality. So that's the meaning. So instead of y, I put v. Instead of x, I put u. And then I put this in a box for future reference, yes? So this is my assumption. So it means that when I choose a point with coordinates u and v on the parabola myself, it means I am respecting this equality. That's the meaning. Yes or no? Okay, now tell me please, because now you just promised me to learn. I am trying to prove that b lies on the same parabola. I succeed to do this if I can show what?
that equality holds.
Which equality?
No,
this equality holds or not. Am I doubtful about this equality to be true or not?
If you change the...
Yes, if you replace y with v and replace x with this expression, it becomes again true. If I can prove that, then I am done. Yes? So I would say that to show that b also lies on the parabola, I have to show that what happens if I replace y with y coordinate, which coincidentally here is v again, and if I replace x with the x coordinate, we have to show that this is true. Yes, is that right? So this, by the way, these steps are not hard to take, but I more or less, I don't know how many of you could do it without my help. My expectation is that if you learn in a proper way, you have to be able to do these things. This is not hard. The hard part of mathematics, I will not consider these questions hard. The hard questions in mathematics is that when you see them, you don't know what to do at all. So you need to do a lot of trials and errors to see if you, in principle, can discover the pattern or whatever. Those are hard questions. But this is not a hard question, yes? You just analyze the problem. You want to show that this is a symmetry line. You need to understand what is the meaning of being a symmetry line. So you really don't need to memorize. This is the meaning of symmetry line. It means that whatever I choose on the parabola, and I find the mirror image of that with respect to that line, it will end up somewhere on the parabola. This is the strategy. And then when you say to yourself that I choose a point on the parabola, this is the English sentence, but it translates itself to this mathematical symbol language, yes? That's the meaning. And then you want to claim something. You are claiming that the resulting point is still on the parabola, so it means that instead of this English sentence, you should be able to prove this. Understandable or not? So this is the strategy, but the strategy is not enough. You have to be skillful in your techniques as well. Okay? Now tell me. We know the grand picture now. We want to prove this. What is the natural step? What is the first thing that you do? Yes, Simon?
Well, you can, since we have both the same type of y-axis, we can just put the equality between the equations to see if the equality holds true.
I understand what you say. Let me just, this is not exactly what I do, but I understand you are right. What I do, this is true. This is true. So by assumption, yes? By assumption. And this is what I want to prove. This is my question mark. So you are right. I want to prove the equality between V and that. So what I do, I will start simplifying the hard part of this with the hope that I can reach to the other side using this assumption. Yes? So you want to show this expression ends up here. What is the natural step to do? Is to simplify this, to see if you can get here. But you will see that when you start simplifying, you will never ever get here unless you use this. And that's okay, because this is true by assumption. These ideas, I will call them, I don't know, anchors or whatever, you need to know them very well. Yes, this is not related to this chapter. This way of thinking is in the whole mathematics. This is the way that you have to think. Yes? So if I want to start, I would say that the left-hand side, the right-hand side here is more complicated. So I start from the other side. Right-hand side is equal to. Okay, now this is your skill in algebra. So you have to know what to do. So if you want to expand this, what is the first thing that you do? You use a squaring rule to expand that, yes? So you have to keep a, be careful. Am I allowed to multiply a first? No. These are technical problems. You need to know very well up to this point. So it becomes the first one squared. Tell me, what's the answer? Do it in your head.
B squared over A.
B squared over a squared. And then
Minus
2 times the first one times the second one. Positive or negative at the end?
negative. Positive.
Because both of them are negative, so it turns out to be positive. So it becomes plus 2b over a times u. And then second one squared is u squared. Yes? And then I will multiply this b in. So it becomes what? Minus what? B times that.
Minus 3
Minus b squared.
Minus b squared, be quick, over a. And then minus bu plus c. Yes? But the expansion is not still finished because there is a pair of brackets left. So I have to multiply this in. Do it in your head. If I multiply a here, what's happening? Everyone.
B squared over A.
B squared over a, because this a and that a squared are cancelled. So b squared over a. And then what happens if I multiply a here?
2bu.
2bu, exactly. Because this a will cancel that a, and then I will get 2bu. And then I have u squared here. Multiplied by a, it becomes au squared.
2b.
And then I have minus b squared a minus bu plus c. Yes? And now what happens? This, whatever this number is, and that number are cancelled. I have au squared alone, so let me just write it here. And then minus bu and positive 2bu becomes finally positive bu. Yes? So I consider this one and that one. I already considered this one. So there is only one single term left, and that is c. Yes? But what is this expression? is V. So then it becomes V. And that is equal to the left-hand side. So I was able to show that this is equal to V. So you see, in this calculation, going from here up to here is always true. But the last step I couldn't take if I didn't know about this. And I know. Is that understandable? So that's the proof. And that's a real mathematical proof. So it means that any point, no matter which point, you choose on the parabola, on the left-hand side, on the right-hand side, doesn't matter. Because you see, I'm just trying to draw a picture for your understanding. But my reasoning doesn't depend on my particular shape. I'm just taking a point on this parabola regardless of the shape of the parabola. Is it opening up? Is it opening down? Nobody cares in this reasoning, yes? So what you see, we were able to show that any point on the parabola that I choose and find its mirror image with respect to this vertical line, I will end up on the parabola again, so it means that that vertical line is the symmetry line of my parabola. Yes? Is that understandable? So that's the proof. The proof is missing in the book, but you don't need to. But I want you to learn. This is like at the right level of your math knowledge. It's not above your knowledge. Yes? So what I'm saying is, so you know actually a lot of mathematics if you can use it in a proper way. Okay, so this picture I want you to remember. It doesn't matter if my parabola opens up. It doesn't matter if my parabola opens down. We always found a formula for the turning point, and the formula for the turning point was always and always this. Yes? But of course, in this case that A is positive, this interpretation of this point is the turning point of the type of a minimum point. And if A is negative, this turning point interpretation is a maximum point. Yes? And there is another name for the turning point, which is more common in mathematics, and they are called extreme points. Yes? So when I say extreme points, means either maximum or minimum. Okay, so that is also one piece of information that I want you to know about parabolas. So we have one single vertical line, and this is the formula for the symmetry line. If I ask you which particular point of the parabola this line passes through, you would say the turning point. So this idea, you need to have it in your head regarding of these symmetry lines. Any questions? Yes or no? Understandable? Okay. Now let us go to something new a little bit, and then I will give you time to practice on your own as well. Okay, let me start with an example to what is my goal. For example, let me give you an equation. I want to solve it for you myself. So this is x squared plus 2x plus 2 equals to 0. Momentarily forget about the second degree functions. Let us go back to the second degree equations. Yes? So let me ask you to solve this equation. So let us go back to the previous lesson. If you want to solve this, you can use PQ formula or ABC formula. Let me use ABC formula. So what is ABC formula? So here A is 1. What is B? B is 2, and C is also 2. Do you remember, it's better to calculate delta. And delta is B squared minus 4AC. And when I calculate it, it becomes 2 to the power of 2 minus 4 times 1 times 2. It becomes 4 minus 8. It becomes minus 4. And it turns out to be negative. So if in the exam I ask you to solve this and you do this calculation on your own, what do you write for me?
There are no solutions.
There are no solutions because delta is negative. Yes? Now, you know this. I change my question. I give you this quadratic function. You see, there are differences here. They are somehow closely related, but this is different. You see, this is an equation. This is not an equation. This is a function I am giving to you, but the right-hand side exactly has the same form. Yes? Now my question is that, if I draw this parabola, can I have, first of all, this number is positive. So you already know that this should open up. But do you think this is a good idea to have something like this? Or do you prefer something like this? If I draw this one, based on what you see here on the board, if you are supposed to just check either this, if I tell you that either this one is true, of course this is very coincidentally bad, so let me just do this like that. Yes. Do you think this is closer to the graph of this one, or that one is closer to the graph of this one? Yes, Tim, and why? What?
The right one.
The right, why?
Because C is positive, so it would be above the x-axis. Oh, wait, no. Anyway, yeah.
Yeah, might be they are true. Might be they are true. But what I'm asking you tell me the reason based on this calculation. Might be you can find a lot of good reasons, all of them correct. But I want you to understand something. I want to understand what is the consequence of this calculation that you see here for choosing which one is the correct one. Yes?
Parabola can pass through zero. So the y can't be this equation y can't be zero.
Y cannot be zero, yes? And what happens for this one?
It's zero.
Y can be zero at somewhere. So you see, if I have this situation, for example, let me consider this one alpha and then let me call this one beta. And this is your function, x squared plus 2x plus, assume that this is true. Then what does this mean? It means that, what are the coordinates of this point? The x coordinate is alpha, the y coordinate is 0. And I see that this point lies on the parabola, so it means that if I replace this with 0 and replace x with alpha, I will get alpha squared plus 2 alpha plus 2. So this means that this alpha satisfies this equation, but this is not possible because we just showed that this equation doesn't have any solutions. Yes? So be careful. This is not the correct one because this tells you that there are two roots for this parabola. There are two zeros for this parabola. One of them is alpha, one of them is beta. But there are no zeros for this parabola because when you put this equal to 0, you do not get any solutions. Is that understandable? Yes or no? So in other words, whenever you have a graph, any graph that intersects the x-axis, so if I give you any graph, yes, and give you, for example, alpha, beta, and gamma, and I give you this is the graph of f function, any function f of x, by looking at this diagram, you realize that if I replace x with alpha, the answer becomes 0. Yes? Because this point has the coordinates alpha and 0, and because alpha and 0 lies on the curve, its coordinates should satisfy the equation of the function, meaning that replacing y with 0 and replacing x with alpha is a true equality. So this is extremely important to understand. Any graph, not just parabolas, any graph that you have, and whenever they intersect the x-axis, when you take these numbers and put it into the function, the right-hand side should be equal to 0. And these numbers, alpha, beta, and gamma, are called zeros, or nollställe, I think in Swedish. Alpha, beta, and gamma are called the zeros, or the roots of this function. Yes? So here, if this is true, it means that there are roots for this equation to be 0. But we already showed that there are no roots, so this means that this cannot be the graph. Yes? Okay, so let me ask you about something else. So what do you think about this? If I solve x squared plus 2x plus 1 equals to 0, so what happens here? If I solve this, you can use delta trick, but there is a simpler way to solve it. What is that?
Squaring root.
Yeah, it is x plus 1 squared. And then how many answers you get? You just get one answer, and that is minus 1. Okay? So, what is your prediction? If you use GeoGebra to draw the graph of this part, y equals to x squared plus 2x plus 1, because it's a quadratic, you definitely get a parabola. Because 1 is positive, definitely it opens up. But what is another good feature what is another feature of this graph? Regarding the x-axis, what do you think will happen? Yes?
It will pass through the -1 on the x-axis.
Yes, what do you mean passing? Passing means,
Or the point lies on the parabola.
so you mean, this is also passing?
Yes.
Something like that? No, better than that. Yes, this is correct. It should pass this point. This is -1. But better than that. You can say better than that. If passes like this, how many solutions you expect? How many intersection points you see?
2.
2. But how many answers you got? Just 1. So you can do better than that. Yes?
The extreme point lies on x minus 1.
Yes, exactly. So you should expect something like this. You should expect that -1, not expect, -1 is the only solution. So it means that, and the parabola opens up. So this means that you should expect something like this. Yes? And this is tangent. Yes? You will see that later. This becomes exactly tangent to this parabola. So this is what you expect, not that one, because there is only one solution. So in principle, if I give you this, so there are 3 possible scenarios going on. Okay? Either your parabola does not intersect the x-axis, or it intersects it at 2 points, or it just intersects the x-axis at 1 point. Geometrically, can you imagine other scenario? No. Yes? And that's exactly what you discovered using just algebraic methods for equations. There are 3 possible cases. Either I have 2 solutions if delta is positive, or I have 1 single solution, which was called the double root, if delta is 0, and if the delta is negative, I will not get any solutions. And that squares with your intuition of these pictures and things like that. I just want you to find a relation between these two, okay? Any ideas? Any questions here? Okay, so this is important to also know. Yes, I think I will stop here today. There is a little bit left from this, so let me just decide about the date for the exam. Do you have any questions regarding this lesson today? Okay, so I will stop recording.